In the previous video, we were able to establish already the Laplace transform of function of t. And generally, that's just equal to 1 over s squared. We're able to solve this in the previous video. You might want to review on that. We're able to come up with that following the formula for a Laplace transform of any function of t equal to the integral from 0 to infinity of e to the power of negative st f of t dt. Now, we may not be using this in solving for the Laplace transform of 5t and the Laplace transform of negative t, but we might be able to include a little bit discussion as to also generalize forms like this. Okay, so this here, the Laplace transform of 5t, supposedly following this formula, will be equal to the integral of 0 to infinity e to the power of negative st. Your f of t is 5t dt. Okay? Now, looking into this perspective, take note that this is a constant. We can always move that out. So you will have your 5 times 0, integral of 0 to infinity of e negative st. Then you will have here t dt. In the previous video, this was already discussed. And later on, this turned out to be the Laplace transform of t, which is 1 over s squared. So what is the point here? I'm not going to show you the process of moving from here to there. But my point here is this. Since we have 5 times this expression, we simply plug in here 5 times the Laplace transform of t, which is just 1 over s squared. In short, the Laplace transform, let me write it here, the Laplace transform of 5t is just equal to 5 over s squared. Okay? So we are also going to generalize it later for the rest of the examples later. But let me continue with the Laplace transform of negative t. As mentioned, if we're going to follow this form, you will have here this is the integral of 0 to infinity e to the power of negative st. Then you will have here negative t dt following the function of t dt. But then you will have a negative 1 here, to which you can always move out. So negative, you have here this form e to the power of negative st t dt. And again, this is just equal to 1 over s squared. So generally, this is equal to negative of 1 over s squared. So with this now, being the Laplace transform of negative t and the Laplace transform of 5t earlier as this, we can now generalize that for any Laplace transform of, let's say, any constant c times t, okay, this is just equal to c, whatever that c is, over s squared. Look into this, 5t, so 5 over s squared. Negative t, negative 1 over s squared. And of course, we know that this has 1t, that's why it's 1 over s squared. So for any c, this is the form of the Laplace transform. Take note of that, as it could also be applicable for other situations pertaining on linearity and such. Thank you very much for watching.